Do you understand how to perform a BFS on a graph? If you don't, watch this question. So we're basically given an array of routes that represent bus routes. And the route I is just like the bus route that the ith bus repeats forever. So for example, the first bus here repeats the first stop, the fifth stop, and the seventh stop indefinitely in this sequence described right here. So we want to find the least number of buses that we need to take to go from our source stop to our target stop and return a -1 if that's not possible. So for this, there's several ways to do this. We're going to use a BFS after we create like a graph. And the general way to do this is we know we want to use a BFS. So we want to create a graph. We want to initialize our queue. And we want to perform BFS. So for creating the graph, I'm going to show you myself making mistakes because I did make a mistake when I first did this. So I guess I want to use the default dictionary here, but I want to keep track of the stops to routes. And let's see. I'm going to do that using a default dictionary of sets. I'm going to iterate over the routes. So for route list and enumerate routes. For stop in route list, I want to add the stops or the route to the stop list. And I did something very strange here. So I'm going to show you what I did originally, and we can just fix it at the end really quickly. So I also kept track of the routes to stops. For intuition on why this doesn't make any sense, the routes here are basically exactly this. So it's just like, creating a second data structure to do the same thing that we already have a data structure for. So anyway, I, created this. I added the route to the stop list and the stop to the route list. Once I have my graph set up, I wanted to initialize my queue. And by initialize, I mean I want to get all of these stops that I can reach from my first stop within one, bus trip. So iterate through the routes that I can reach from the first stop. Iterate through the stops that I can reach from the routes that are described. Add them to a queue, which I didn't initialize, so very funny. Anyway, add them to a queue. Yeah, that is right, isn't it? Yes. This is how you initialize a queue. I want to append the new stop. And actually, let me describe what's in our queue. We want to have, let's see, what do we call this? A cost, or not a cost, a distance, number of buses. That's a good way to put it. And then the current stop, I guess. So number of buses here is 1. The current stop is just this stop right here. And for another sort of hint to what I'm doing wrong, think about whether or not we need to actually store our stops. We don't, but yeah, just think about that. So now we have this queue set up. Let's just run this to make sure that my queue looks as expected. Okay, so I definitely forgot something. I called it spot instead of stop. Okay, seems reasonable. So our queue looks like we would expect it to. We're adding each of the stops along with their number of buses to reach that stop. So now we want to perform a BFS. So while there is stuff in the queue, we want to pop that stuff out. We want to pop out the number of buses and also the current stop. How do I do that? Definitely should be a pin left and then pop. Poop. Okay. Once we have our stop and our number of buses, well, first of all, if we've seen a stop, if we see our stop, like the target, which is called target, okay, we want to return the number of buses. If we've seen the same stop multiple times, we don't need to explore that after the first time. Seen stop is equal to set. And this is because, when you have a BFS, you're processing the min things first, basically. You're increasing the distance by 1 each time here. So if you see the same thing multiple times, then there's no reason to keep on exploring. So if stop in scene stop, we want to just return, or I guess continue, just skip past it, add it to the scene stops. If not, then we want to iterate through our routes that are available from our current stop. So for route in stops to routes, I like that I name these intuitively. I don't have to look back up at what they're called, although I guess I can see it. If we've seen this route already, we can skip it for the same reason that we can skip the stops. Let's just copy and paste that in. So route in scene routes, we can just skip over it, and let's just copy and paste to populate that scene routes as well. We want to get the new cost for, actually, I guess that's not correct. New cost is a weird way to say that. So we want to get the new stop. Next stops? I guess maybe that's a better way to put it. We want to get the next stops. Did I say steps? Stops from routes to stops for our current route. And, we just want to append that to our queue. Append left, actually. And that should be, I guess, next stop. It's a single stop. The stop is first, right? No, it's not. The stop is second. And the first thing that we pass in is going to be our number of buses plus 1. Let's see what happens when we run this. I'm sure it'll be wrong in some weird way. Scene routes. Oh, I forgot to initialize scene routes. Now let's run it again and see what happens. Okay, yeah. This seems fine, but who knows? Let's submit it. So we got... Oh, right. I did forget something very simple, which is that if we've seen the source and it is equal to the target, we can just return 0. Rookie mistake. Anyway, that works for our first version of this solution. Now let's talk about what I did that was weird. First of all, no reason to store the routes to the stops. We're given the routes already, right? And this is just a mapping of indices to the stops that belong to them. So there's no reason to actually keep track of the routes to stops. We already have that information. Yeah, let's see. Route. That looks more reasonable. Routes to stop. So let's try to see what happens if we submit this again. It looks like it was accepted again, which is what we expect. Now, what else did I do that was weird? The most important thing to realize is that there's no actual reason for us to look like stop by stop. We can look route by route instead. If you can reach one route from another, it doesn't really matter, which stop you're at. So there's a way to optimize this further using that fact, but that would take a while, and I'm tired. So I guess I'll continue this in part 2.